In this video, we're going to take a look at the sun. So by the end of this video, you are going to be able to describe the sun's characteristics, as well as be able to describe the importance of the sun and the sun's role in sustaining life on Earth. Let's begin by looking at some of the characteristics of our sun. First of all, its size is over 100 times greater in diameter than the Earth, so it is 1,390,000 kilometers in diameter. The mass is one of the largest stars in our Milky Way galaxy, and the mass of the sun is over 300,000 times greater than that of Earth. So it's 2 times 10 to the 30 kilograms. So that is a 2 followed by 30 zeros. In terms of its distance, the sun is 149,600,000 kilometers, or 92 million miles from the Earth. The distance from the sun to the Earth is also called an astronomical unit, or AU. At this distance, it takes the light slightly over 8 minutes to get from the sun to the Earth. Finally, in terms of its composition, the sun is mostly hydrogen, so it's about 70% hydrogen, 28% helium, and about 2% of it is metals, such as iron. Now, what we want to do is we want to take a look at what the sun is composed of, its different layers. And so the sun and its atmosphere consists of several zones or layers, and we're going to look at a quick peek at the layers from the inside out. So let's start, first of all. The internal structures of the star consists of the inner core, the radiative zone, and the convection zone. So let's talk a little bit about each in a little bit more detail. First of all, the inner core is the central region where nuclear reactions occur. And so these reactions will release the energy that ultimately leaves the surface as visible light. The radiative zone is characterized by the method of energy transport, which is radiation, and that's where its name comes from. And finally, the convection zone is a region of turbulent plasma through which energy is transferred by convection. So again, that's where its name is coming from. Looking at the next layer out then is the subsurface flows, and this is really just an area or region that separates the sun's core from the outer shell. If we now step out to the next, we've got the sun's outer shell or solar atmosphere that's made up of the photosphere, and then the chromosphere, and finally the corona. And so the photosphere is the deepest layer of the sun that we can actually observe with our eyes. The temperature in the photosphere varies from about 6,200 to 3,700 degrees Celsius. That's followed by the chromosphere. That's an irregular layer above the photosphere where the temperature rises from about 6,000 degrees Celsius to about 20,000 degrees Celsius. And finally, the corona is the sun's outer atmosphere. And so temperatures here are upwards of 500,000 degrees. The corona can't actually be seen by the naked eye either, unless we have a total solar eclipse, or we use special equipment to be able to see it, such as a coronagraph. Beyond the corona is the solar wind, and this is actually just an outward flow of the coronal gas. So now what we're going to do is look at a few solar phenomena, and these are pretty neat. The first one are sunspots. So a sunspot is just what it sounds like. It's a dark spot on the sun. They're formed as heated material rises, reaches the surface, cools, and then sinks back. They are not constant. They appear and disappear as magnetic fields move. The next one is solar flares. And so the process of creating sunspots opens a connection between the corona and the sun's interior. Solar matter surges out of these openings in formations called solar flares. These explosions are massive. So, in a period of a few minutes, solar flares release the equivalent of about 160 billion megatons of TNT. So, that is massive. Solar flares are actually also felt on and can cause disturbances to our atmosphere and magnetic field on Earth. They can disrupt satellite and telecommunication systems, so we do feel their effects. Finally, the last phenomenon is prominences. And so a solar prominence is a large, bright plasma loop that extends outward from the sun's surface. They can be stable, so a stable prominence may persist for several months, looping hundreds of thousands of miles into space. Now, scientists are still researching how and why prominences are formed, so this is an area of research that is still ongoing. So now let's take a look at the sun's energy source. So in the core of the sun, hydrogen's being converted into helium. And this is called nuclear fusion. And so fusion happens in the middle of stars like the sun. As hydrogen atoms are fused together to make helium, a lot of energy is released. And this tremendous energy powers the heat and the light of the star. It can even be described by Einstein's famous equation E equals mc squared. Finally, let's take a look at the importance of our sun. So our sun is absolutely essential to Earth's ecosystems. It makes plant life possible. Without the sun's warmth and light, Earth would be negative 273 degrees Celsius and life on Earth would not exist. So sunlight provides necessary light and energy to plants and other producers in the food web. These producers absorb the sun's radiation and converts it into energy through a process called photosynthesis. Plants are the foundation of the food web, and their energy and nutrients are passed on to every other living organism. Some other interesting facts about the sun and its importance to our life is that it produces day and night cycles for us. It also is a source of heat that drives climate and weather systems around the world. And the sun's gravitational pull actually helps to keep our Earth in orbit. So now that you know a bit about the sun's characteristics and its importance to sustaining life on Earth, let's move on to our next task.